The project that we're going to discuss today is called GSM based intelligent home security systems for intrusion detection. The outline of the project includes a system overview, design considerations / architecture strategies / system architecture, a detailed system design, invention details, which includes the objects of invention, a brief description of the drawings, and a few working examples. There is also implementation shown in the project, which includes a copy of the pseudocode. So the system overview consists of the following slide. Our GSM security system prime goal is security through intrusion detection and notification. It is based on smart security where users can comfortably install the security system in any building and get maximum security of users' property and organization. At the beginning, we had a few basic requirements and we decided to add more features on further research and discussion. The design considerations include the architecture of the system, which has a microprocessor, a householder phone or your cellular device, a GSM module, which includes an antenna and the power source, and there is an alarm, or since we are using the GSM module, we won't really need the alarm, we'll just need a silent text or a phone call. So this section briefly describes the different hardware components used in the design as well as the software algorithm implemented in the embedded microcontroller unit. The system design includes the firmware design. Firmware is designed and defined as the low-level software or programs that are written onto programmable devices, which enables it to determine its capabilities, render them functional, and coordinate operations. In order for the developed prototype to work, the microcontroller should be burnt with a firmware. For the multi-home alarm system, the firmware was programmed using C language. Each module was tested if it was working properly. When confirmed functioning, the system was programmed and conditions were set. The microcontroller unit would command the GSM unit to send an alarm message to the user notifying that smoke was detected in the area where it was installed and would prompt the user to notify the police department. The hardware design includes a passive infrared sensor or a PIR sensor, which is used for intrusion alarms. SIM900A is the GSM module used in the system, as SIM900A delivers a quad band GSM GPRS which can easily be embedded in electronic applications. It has low power consumption and can fit easily in space compact designs. The microcontroller used is Atmega 2560. This was selected because of its compatibility with module interfacing, direct program coding, and modification. The microcontroller Atmega 2560 stores the program for operation of the system. Backup power supply was used in the system because of its portability, ability to recharge, and considerable energy lifespan.
Objectives of the invention. First is to develop a cost-effective prototype of a multi-home alarm system that can send notifications to users using the GSM technology. Another object is to improve the performance of the various devices which lie in close vicinity of the user. to propose a model that provides ubiquitous system for security. Yet another object is to analyze different automation techniques for classifying in anti-theft security systems. One more object is to increase the standards of electronic security system through the various approaches given. So, a brief description of the drawings. Developmental research method was used in the study to come up with a working prototype of the system. It is comprised of hardware and firmware designs. Hardware design consists of hardware assembly, interfacing, testing, and troubleshooting. And firmware design consists of writing code using the C programming language, error debugging, and testing. Some working examples. Consider a case where user puts the control unit comprising the microcontroller and GSM module which is connected to the vehicle. Once the theft takes place, an interrupt is given to the controller, which in turn generates an alert message and transmits it to the owner of the vehicle via the GSM modem. Another example could be, for example, take a case where the user uses the system to find the breakages or cracks on tracks in electronic locomotive system and alert the railway department. It is one of the latest technologies to be used to avoid railway accidents. What we do here is use a GSM communication protocol to send the message of breakage detection via an SMS. The microcontroller can be used to process this data and convey it through required communication protocol.
So till now, as we have discussed the working examples of our project, now we're going to discuss about the flowchart of our project. So how actually the PIR sensor sets its parameters and how it actually detects the motion. So when we turn on the Arduino, it will set the parameters accordingly as it adapts to the surroundings, and once it adapts the parameters accordingly, it will sense any motion after that. So once it detects any motion, it will check with the parameters it has been set before. So after that, if there is a check matched, it will send the alarm text or a phone call to the user, and the user can function accordingly on the basis of what message it has he or she has got. So this is the basic workflow of our project. Now we're going to discuss about the pseudocode of our project. So as we know, we have discussed about this earlier also, that our PIR sensor will send a high input to our Arduino, which we have already set as PIR output 8 on the pin mode 8. On the pin number 8, we will get the input from the PIR sensor, which will send high or low. If the PIR output is high, we will work accordingly. If the PIR output is high, we will send, according to this code, we will send the call to the user first, and then we will set the mode to a text mode, which will send the message to the user accordingly. So we have this as set this as warning intruder alert, which is a message which will be sent to the user, and at the end we will end the message with the 0x1a character. So this is the pseudocode of our system, and we have referred a few research papers on the basis of which we actually implemented our project. So thank you so much.